Hello, everybody, and welcome to the session on avoiding API silos in a multi-cloud world. I'm Dan Temkin, Senior Product Manager for API Connect at IBM. Originally, if you had looked at the schedule, you might have seen that Callum Jackson was originally supposed to talk. He was unfortunately unavailable to come stateside due to some personal issues, so I'll be taking his talk, but I definitely want to give him a call out, being that he helped me put together all this material. So to start with, let's lay a foundational aspect of is multi-cloud, is that world's real? Is this something that we're seeing across all of our accounts? And it really is. We can look at different statistics coming out of Gartner and S&P Global, Flexera, that provide multiple different aspects of organizations are adopting a multi-cloud strategy. I can say with my engagement in different organizations, going and talking with different clients from around the globe, when I ask them, how many clouds, whether it be hyperscalers, individual hosted data centers, colos, are they dealing with? Most of them always say we're dealing with more than one. Even if they are saying we just have one hyperscaler of choice, they still usually have an on-prem data center. And even that hyperscaler of choice is just the choice. It doesn't mean that's the only location that they're putting out their applications and services out into the deployment ecosystem. So when we look at API management and API gatewaying, when it comes to looking at that multi-cloud world, we start seeing some challenges because we have different personas pulling us in different directions. So we have a lot of this work coming out of the IT side of deciding how I'm building my applications, how I want to deploy it, really focusing on that delivery dates, how fast can I get something out into the real world. And again, going from our keynote session early this morning from David Mutter around that it really should be the business driving what is the outcomes and goals of an API management solution and providing APIs out to the business. And we're really seeing from a common cloud platform standpoint, a lot of it being led by the development teams. They're focused on what is the easiest way to expose my APIs from my business services, my Java, .NET, Node.js applications out to the rest of their consumer base, whether that be internal or external. So often they're choosing the platform provided API management tools, whether that be things like Azure's API management, AWS API management, and choosing these platform services because they are easy, they are turnkey, they're built into the platform, and they can be done with limited knowledge of API management technology. But this starts creating immediate silos in an organization. And this is the same, by the way, this is kind of the what's old is new again. If I had multiple different gateway technologies, API lifecycle management technologies in my organization, I already may have created individual silos inside my organization. So this is just being exacerbated now when we look at a cloud platform. So I might have things like AWS where I have an API, lightweight API gateway that supports TLS 1.2, supports JWT, only JSON, so hopefully we're not doing a lot with XML, where if I go over on the Azure side, I might have a different capability set that I can leverage APIs with, where I do have OpenID Connect hosted through Active Directory, so it's again that spin on things. I can support XML and JSON. I do have some transformational support through XSL, where AWS, it's a scripting language model. And again, we're really focusing here on the APIs that are multi-cloud exposed APIs. So if I'm within an application, so again, thinking about the application boundary layers, if I'm inside of an application, I can expose APIs, and that's great. I'm probably staying on platform. I might not be integrating across a multi-platform spectrum. When I'm within a cloud exposing APIs, again, I'm breaking the application boundaries, but I'm most likely staying in cloud. But once I start moving across that multi-cloud exposure point, I want to hopefully have something that drives out consistency. Now, as a developer, I might, as an organization, might only be focused on building my applications on AWS because that's where my skills as a developer come from, where another team, another squad might be building all their services on Azure. So they have different skills. But that also means the portability of my skills when deploying out APIs is locked into that platform because I'll have to relearn how the different platforms deliver APIs in a consistent fashion. So there's a problem, though, for the enterprise. I mean, this is easy for the developer, kind of going back there. If a developer is just building things on their platform of choice, great. It's easy to deploy, and they can work within the boundary lanes of what that platform offers. But when we get into how does this work for the enterprise, we start entering a multitude of different problems. So, and I come from the insurance and financial standpoint. So my first concern is, okay, security. How am I going to make sure that the data services, those business logic that I'm exposing, can be done in a secure fashion? So when we look at from an enterprise standpoint, each of the different iPaaS solutions offer different security controls. They have different ways they've implemented security standards, and they don't necessarily all have parity in what security standards that they offer for those APIs coming through. So what ends up happening is a CISO office that's trying to implement an enterprise security model is going to have challenges going, well, I can easily implement certain governance on one platform, but I have a trouble implementing in another. And how do I maintain consistency? And then also when I want to move an app, maybe from cloud vendor 1 to cloud vendor 2, can that vendor actually provide me the same security capabilities? Or do I really have to rethink, okay, what am I able to expose? Sometimes unlocking the latest security standards like TLS 1.3 is not commonly available yet, and it's slowly rolling out. So also deciding how fast and edge forward do you want to be when adopting new standards. And then of course, expanding the attack radius. The more different systems that I have to figure out how do I operationalize them from a security standpoint, the more complexities I get and the more likelihood that we're going to introduce either human error or process error when trying to secure the systems down. We're also going to introduce things like constrained visibility. So if I have different cloud providers, again, one platform providing APIs for the APIs hosted on that platform and different for the other platforms, I'm going to have things like analytics is going to be tied only to the services on that platform. Same with health and monitoring. So suddenly my operational teams are going to be like, I've got to look at multiple different cloud platforms, because right now we're just talking about the exposure of the APIs, not the consumption. And most likely the consumption of these APIs, especially when we talk multi-cloud APIs, are going to be a single consumer consuming APIs across multiple clouds. So I'm going to be, as a consumer, opening up a support ticket going, my services aren't working, and now trying to figure out where do I properly route those tickets based on what the endpoint's actually being hosted on. And so there's really a large challenge around insight and that monitoring and observability. Next is really that fragmentation of knowledge and skills, which I already kind of alluded to. As, again, an API provider, as that developer team, I'm going to be very tied to that platform that I'm deploying on. So if I want to have the flexibility to go, oh, we originally built our application on Cloud Platform 1, but I found that the data and business intelligence services on Cloud Platform 2 is better, and my application would be better suited to be deployed over to that other cloud platform. Now I've got to move my full vertical stack, including my API exposure point, which is the API gateway and management model, over to that. So I'm kind of shifting where my knowledge needs to be and constantly pivoting, which means I'm spending more time focused on the technical aspects of delivering the API and less time focused on the business delivery, which is really where the value comes to play. And again, things like hard to provide constant guidance. So when we talk about that, the ability to enable a large group of API developers inside an organization, if I'm having to provide guidance that's specific to different provider systems, again, I get a sprawl going on that really provides hard to have both guidance and governance when it comes to that. We already kind of did allude to inconsistent feature set. So when we pulled up that that first diagram that had some had one system, some had another capabilities. So what ends up happening is teams start going, well, I'm going to build on the lowest common denominator of just saying the API management platform is just going to expose an API, and I'm going to write a lot of code into my business application to handle the things that are not provided by all the different API management platforms, which means I'm going to either not be able to leverage the features from one provider or another, or I'm going to, again, write a lot of code, which is increasing our operational costs, possibly increasing our security exposure, because now the organization itself is having to manage it. And we're seeing that the cloud vendors are slow to adopt new standards, such as GraphQL. Again, inconsistencies in what they're offering. And lastly, we get a kind of this divorced API lifecycle of I might not know if I'm calling the correct API version. The different iPaaS platforms handle versioning, handle environments differently with the URL structure. So when I'm looking at it, again, either from a provider, from an operations team perspective, or a consumer, am I actually calling the right endpoint? Am I calling the latest version? None of these are necessarily documented the same way. So you get into this, the danger of applications kind of just falling out of the life cycle, kind of leveraging shadow APIs or Frankenstein APIs that are on the old side. Not sure if you're deprecating them out and moving consumers to the latest and greatest, especially if you start saying, well, the API used to be hosted on Cloud 1, and now we're going to start moving the new versions onto Cloud 2, because now it's up to you as an organization to figure out how are you going to do a centralized catalog to find all the APIs that are sprawled. And I've already alluded to some of the problems that we see from an app developer standpoint. And to me, this is the bigger problem. API lifecycle management should really be geared towards the consumer, not the provider. When we look at who are we making this easy to expose APIs for, a lot of times we spend a lot of time focusing on, I'm an app developer, I'm trying to get my API provider, I'm trying to get that API exposed so someone can consume it. We're trying to make it as easy as possible for that persona. But the reality is the APIs are being created for our app developer to consume, to provide that optimal user experience. So how can they take lots of different API assets, collections as products, from a business capability set, and deliver APIs either where they're developers that are inside your organization trying to deliver new services, that they're external partner developers, mobile app developers. So if you have all these different API silos, it makes it much harder for them to go find, how can I find all those assets to build that composable business. And I look at it a lot like if I was again, I came out of the insurance and financial area. If I was a company and I said, oh, I have a mobile app specifically for my credit card. I have a different mobile app for my savings account. I have a different mobile app for my investments and a different mobile app for my insurance. That's the exact same siloed experience that you're giving developers when you say, oh, you have different API collection sets on different clouds that are all siloed apart from each other. And we'll see how that kind of gets a little further as we go into these pain points. So firstly, we have multiple developer portals, each one with separate onboarding processes. How do I check out an API key? How do I manage an API key secret? If I need to do things like mutual TLS, if it is even supported on those platforms, how do I upload my certificate material to make sure that I can provide that proper handshake? How can I validate my current API utilization? So again, I might be calling multiple different endpoints, and I want to make sure that my consumption is right. If I'm getting rate limited, why am I getting rate limited based on those, especially if I'm getting a chargeback model, direct monetization. I want to know my API utilization calls quite easily. And if it's spread across multiple portals, now it's up to the consumer to go in and try to figure out, okay, what's the status of this account, status of that account? Why am I suddenly being blocked on the third account, even though I need all 3, 4 of those to to get APIs that compose my business application. So again, continuous confusion, slowing things down. If we look at that goal of agility for organizations, this is a counter to having an agility model. Security, of course, being the next big challenge. There's that inconsistency between security between multiple cloud providers on how they handle things, even just issuing out API keys and secrets. Do I have to get an API key for every single resource endpoint that I'm calling, or do I get an API key that then is tied to a collection of subscriptions that I can reuse across multiple resource endpoints? All of these, and then also being able to check out new API keys while having my old ones still in place so I can do rolling changes versus having to do hard cuts. All of these different things change the way the app developer has to think, because they're going to, again, tend to roll back to the common denominator of what all the different platforms support, which means that you're not going to get the best user experience, which means that the feel that they're going to get out of consuming your APIs is not going to be the greatest. And lastly, that inconsistent feature set. So where the developers are going to kind of have that higher cost due to frustration. They might be saying, oh, all those platforms only support REST APIs. I would really love to have a GraphQL API, but you don't offer it. So now I have to call for that resource. I'm going to have to do hundreds to thousands of calls against that same resource to aggregate that whole collection versus a GraphQL set of calls. I could have made a single call and getting that full graph set back. Same with things like async APIs. If I do with event-driven architecture, I want to be able to subscribe to the events that are going on, be either a subscriber to events that are being generated as a consumer, or being able to produce events into a system. Being able to do that alongside my REST and GraphQL APIs, how can I best leverage that experience? Well, if all the different platform vendors don't support that equally, then again, you're going to provide that inconsistent experience. So again, frustration both now from the API provider side and the app developer side. So I wanted to, let's see, there we go. Before I get into it, I was going to go and just show a quick demo, and again, to help with the not having the demo demons pick me up today and drop me, I decided to do a quick video here. So this is going through the standard process of an AWS API creation. So you're going in, we're picking up a YAML, we're looking at, okay, how do we take that in? What type of endpoint do we want it to be? Is it regional? Is it private? Is it an edge? Which means I get different functionality that's available to me based on the type of API I've selected. So I'm already going as a API provider, I'm already making decisions that's limiting what I'm able to do. And in this case, we're just exposing a simple Lambda function, again, just as a kind of proof of concept example. You could be doing a much more complex API, of course. And we're going to mark that the API key is required to add some level of ability to audit that transaction set, to provide some level of security. As we're having to work with inside this API definition UI, which is again very specific to AWS. So now if I'm deciding to do this exact same thing in Azure, which again, just due to timing, I'm not going to play the Azure video, but we did the exact same thing. It's a completely different set of screens. It's a completely different set of flows that you do. What I'm looking for to get the same functionality, or at least similar functionality, is different. And again, we're able to create that hello from AWS via our AWS API gateway, publish it out, do a quick test. We're deploying it. Again, each platform has their own concept of what a deployment is, what it means. AWS puts that in the URL path. Azure does it differently. So again, you're not providing that consistent experience, which then makes things like having a high quality taxonomy, if you were in the other session right before mine in the other room, or if you're trying to build those good business objects and business processes encapsulated in an API, it gets really harder because now the developers are trying to just, how do I take these screens and just get to that exposure point? And finally, we're able to define this usage plan, set some basic rates, which again, I don't have a lot of capabilities here when I'm able to set rate limiting and throttling. But I can at least do some basic stuff, and finally I can add this API stage, or the API to my stage, build this all together. A lot of clicks. Oh, I have to go create that API key in secret, which really is from an AWS standpoint is done from the provider side. So I got to either decide to stand up an API portal, which is not done by default, or I have to issue that out manually to all my API consumers. Grab this key and finally get to that point where I can run a quick test to validate that the system actually works. So as you can see, it's a lot of steps. And imagine that every platform I go to is going to be different. So if I choose now to build this exact same service in Azure, all the steps are going to be different. And no matter how close I try to make these APIs, some of the HTTP headers, the way the different platforms format them are going to be different. The error codes that the platform generates that are outside of my control, those default error codes, are going to be different. So I'm not going to have that consistency across the platforms from a consumer exposure standpoint. I can get close, but I'm going to have to do a good amount of work to get there, and spend extra time teaching my developers how to do it, as well as I'm still going to have all those problems of, do I have the same capability sets across the different platforms? So we've seen customers, and we've talked with a lot of customers, look at different tactical options for how they look at solving this. Probably the simplest one is I federate all my API exposures at a single portal. So I have a single portal that I do publish out that's inside of one of my cloud providers. It ends up more being a discovery point, often does not support all the subscription and lifecycle capabilities, can end up being out of sync between the different cloud vendors unless I build a really tight DevOps process to publish all the APIs out to that portal and make sure that if I'm changing the lifecycle in one cloud, that I'm federating that information out to the portal. And then again, I'm having to determine how am I going to cleanly support all the different documentation, from security documentation, from the payload format documentation into that portal. And again, it's usually just discovery, not full subscription, because all the different ways the providers handle and subscription is different. So if I'm subscribing to an API and I need to get a new API key and secret on one platform, it's going to be different than on another. So this is one option that we've seen. Another one is double exposure. So now suddenly I'm going to say, all right, I'm going to put all my APIs and have them exposed on one platform gateway, and I'm going to have duplicate APIs exposed on the other gateway, and I'm going to use one gateway to decide, all right, which cloud does this service really exist in? So suddenly I'm calling maybe to AWS, or having all my, in this example, all my calls go to AWS, but half of my services actually exist in Azure. So now I'm dealing with cloud ingress cost and data transfer cost between the clouds, additional latency. I do get consistency because I'm now going through one gateway, but now I have a bottleneck of everything needs to go through one cloud vendor. So now I might not have the same type of regional flexibility if I want to have my services existing in multiple regions across a global landscape, being able to go, well, now if this one site goes down or the DNS for that one area goes down, or I have a slowdown in that vendor cloud space, I might have problems. And well, let's be honest, that's happened on pretty much every hyperscaler has at some point in time had that. So do I want to have that impact all of my services, even the ones that don't exist on that platform? Probably not. So one of the things we can say is, well, and we see a lot of companies say is, okay, we're going to solve this by only going to a single cloud. And we'll put all of our services in one cloud, and that's it. We'll choose one hyperscaler of choice. But the reality, again, going back to our first analysis slide, is that we do have multiple clouds out there. That federated gateway model is going to be needing to be required. Different cloud vendors have different capability sets that are better than others. That's why we kind of go to them. There are different pricing models that I might want to take on. I might want to also have the flexibility that, hey, one cloud vendor might be really close to my business industry space, and maybe not today they're not a competitor, but tomorrow that provider might be a competitor, and I want to have the flexibility to move my services around. So we really look at, from an IBM standpoint, a way of de-siloing our APIs. And this is really geared towards making sure that we can have a consistency with choice model. So this is IBM's API Connect platform. And I want to highlight here, and this is a big difference, and this is really going to be the only time we're going to see this, except when I point out in URL paths. We have our default availability zone that we've deployed a gateway into that's on IBM Cloud. We've also deployed out a Azure East deployment gateway that's, again, an API gateway managed by IBM, as well as an AWS gateway running in London. So we have got multiple gateways out there that are going to be supporting traffic across multiple cloud platforms. But from a consumer standpoint, they see one gateway type, they see one interaction model, one security specification, supporting all those different platform types. So we'll keep going on here. And we're going to see a lot of commonality between when we start getting into the creation of these APIs, from a provider experience, and then delivering a unified consumer experience as part of this. So let's go ahead and pull up our developer here, which is a full graphic developer where I can create REST APIs, whether it be REST JSON, REST XML. I can create GraphQL-based APIs. I can do async APIs. In this case, we'll do a simple REST JSON API. Again, we'll pull in that same greetings YAML that we used in the previous version. So it's an open API specification to API. It's portable. It's flexible the way we'd want it to. And we're just going to go ahead and rename it to Greetings Europe, because remember, I have that one cloud provider in Europe. We're going to go ahead and generate our API structure in API Connect, where I can go ahead and add additional metadata as well as configure our gateway policy. So our gateway policy is what functionality do I want to have the gateway provide. Now notice, there wasn't the choice of, is it an edge gateway? Is it a private gateway? Is it an enterprise gateway? Is it a micro gateway? From our perspective, it should be one gateway policy, regardless of if I want to have a form factor that's a hardware appliance sitting in my DMZ to a container, a single core container running in a horizontal pod autoscaler running in a Kubernetes cluster. We're going to make sure that we give developers an easy to use tool. So we provided a full open API specification editor for all the open API specification contracts, but here where they're actually developing the gateway policy, we're able to do it through a drag and drop user interface where I'm setting up some context variables, pulling in the schema that was already in that open API specification, and doing some nice drag and drop to say, all right, I want my input string to map out to an output string in a specific segment of my JSON. And then I can leverage common JavaScript, which we run in what we call gateway script, which is an isolated runtime from a security standpoint. So it's running it from server side under a memory context. So we get runtime security with it. So there's not crosstalk between the threads. And with that, I can turn the API online. And I can start testing it right away on the gateway with that single click up at the top where I marked online. We can jump over to our test. We automatically generate that client ID and secret, so I don't have to go again and say, okay, generate a client ID and secret just to run that test, which we had to do on the other platform, and able to get that, my greeting, hello, AWS from API Connect on AWS. So again, we are calling to an AWS gateway. It wasn't just that we were, marshaling that on our internal IBM gateway. And so just because, so we end up with a centralized management with remote gateways across all those different cloud vendors can provide that consistency. So we'll go ahead and pull in yet another API. Now, the reason we're doing this is so we can have a slightly different configuration when we deploy it out to a different endpoint. So I want my Azure API to be slightly different than my AWS API, but I want them to be consumable as a unified product. So if I want to subscribe to my greetings collection, again, imagine this is something a little more business impactful from a collection standpoint, I can subscribe to the greetings collection and have access to either the Azure API or the AWS API without having to go and subscribe to those individually. So my one API key and secret works for both. The life cycle of those APIs are all managed together. So again, we'll go ahead and do that. A similar mapping step. Let me jump forward just a little bit here. I was talking a little faster. So again, we did those exact same steps just to save us some time here. So I've got two different APIs. We're going to bundle that into a product. So API Connect has a built-in concept of products where I can join like APIs of different types. So I could have a GraphQL, a REST XML, a SOAP API, all bundled in the same product if I wanted to, as long as it makes sense from a consumer standpoint. This gets into that, why we really want to have people that are API product managers thinking about what's the right collection of things to provide a business product. Here's where I can define my plans, publish it, set visibility and subscribability if I want to limit access to that as part of the developer portal. And we take care of creating that and then publishing that out to a developer portal. So we have an integrated developer portal, so that way consumers can be self-service. So we're going to go ahead and create another product for our Europe publication. And we'll select the APIs that we want for Europe. And go ahead and do the default plan material. Again, select visibility and subscribability. An API connective, when we talked about earlier about lifecycle, we've built in this concept of lifecycle into our product where I can say, I want to take something and push it out to stage it into an environment where it's out in the environment but not ready to consume. I want to take it and publish it all the way out for consumption. So we're publishing it to I'm going to pause it really quickly here. So we're saying I want to publish it to a catalog called multi-cloud, and a catalog is that developer portal that I'm going to be able to go to as a consumer. And I'm going to specify that the product I'm currently publishing is only going to go to the AWS gateway. So I can specify, even though that catalog has multiple gateways attached, I can specify which gateway do I want to have it go out to for that service. And I'm going to do the same thing now for my other Greetings America API. Go ahead and specify that publish of product. And this time, instead of selecting the Europe gateway as part of that, the gateways that are published for that catalog, we're going to go ahead and publish again to a specific gateway service, decheck the Europe, and send it specifically to our Azure gateway. So now I have my Greetings America sent to Azure, my Greetings Europe sent to AWS. And I can go to our developer portal, which is, again, is a fully integrated portal. When we publish, we automatically publish out to the portal for consumption. I can sign in either through a user registry that can be defined as a standard LDAP, Active Directory, OpenID Connect. We have a built-in user registry if you don't have one that you want to leverage. Again, providing a lot of flexibility there for providing external consumption. You can have it where you can have self-service registration or be able to register in a more prescriptive fashion. So we'll go ahead and create an application. So again, now I'm in that, changing that persona of an API consumer, where I want to consume APIs. So I'm going to create my test app. It's going to generate out a key and secret for me. And again, this is a key and secret that I can use for any of the subscriptions in that catalog. So I might have 10, 15, 20 products. I could subscribe to all those products, use that same key and secret against all those endpoints. So I don't have to worry as a developer, oh, do I have the right key for the right resource endpoint? And have to constantly manage that list of keys to the list of resource endpoints that I'm trying to call, because those can easily get out of sync. It's human error for typos. One of them gets changed or modified. So I can call, subscribe to my Greetings America. And again, we'll see that we have a, we're calling our load balancer that's part of the Azure endpoint here in Cloud App. And we get our test that hello, everyone from Azure, API Connect on Azure. So even though that backend business service is hosted on Azure, we get a unified experience. And that's, if we walk away from one thing about de-siloing our APIs, it's providing that unified experience for both the API provider who's trying to build out APIs for their backend services that they're exposing on those platforms, as well as, and to me, more importantly, the unified experience of the API consumer that's trying to build their applications to consume and subscribe to all those APIs, so they can have that visibility of services that you have in your catalog. And we'll do that same try it now with the Amazon AWS service. So again, providing services across that multi-cloud with a unified experience. So go back to my slides here. So the needs of the API developer in this multi-cloud experience, and a big part of it is that freedom to deploy anywhere. I want to have consistency with choice. I want to be able to say, I can build it today, develop my API today, and it can be deployed on-prem on a gateway that's hosted as a physical appliance or VMware appliance or container. I can deploy it on cloud as a cloud-native gateway. I can deploy it as a Linux-based system. No matter how I'm deploying it, I get that consistent experience and then the flexibility to change where it's deployed without having to completely rewrite the service and go back from scratch. I be able to take the portability of the security that I embedded into that gateway policy and bring it everywhere I need. And then, of course, from a DevOps standpoint, because I'm pointing everything, all my DevOps scripts are pointed to the manager, and the manager is taking care of publishing it out to all those different gateways. I can have a unified DevOps script that says, oh, in this DevOps pipeline, I want to be publishing this to Azure. So I just set that flag. If I want to be publishing everything to AWS, I just set a flag for AWS. I call the same exact manager. The manager is taking care of which gateways am I routing that traffic to as part of it. So that way I have a consistency in my assets. I have less chance of configuration drift. I have easier ability to meet security compliance. And so when we look at it from the app developer standpoint, I have a streamlined approach. All the APIs that I'm consuming of your business, again, if I'm an internal developer or an external developer, are going to feel unified. I don't have that leakage of platform, of where are you actually hosting your APIs. Sure, the URL endpoint, if I'm calling the endpoints of those different cloud providers, I'll be able to see it there. But the actual runtime experience of the common error codes that I'm going to get back, the REST formats that I'm going to receive, the way I discover them through the portal, subscribe to them, that full lifecycle aspect is going to stay consistent. And that makes a delightful experience. And at the end of the day, don't we all love a delightful experience? We want to make it so it's easy to consume APIs, because at the end of the day, my goal as an app developer, especially as that consumer, is about building the application that's trying to pull data from all these APIs or interact with these services. My goal is to spend as little as time about actually trying to figure out, how do I subscribe to each one of these things? How do I onboard myself into that process? Being able to have that same look and feel means I can kind of jump into any of your business APIs with consistency. And I look at it a lot like, if I always drive the same car, I know where where the blinkers are. I know how to turn on the windshield wipers, and because I'm used to how that car works. If you jump into different rental cars a lot, at least for me, one of the things I get flummoxed often is, okay, how do I properly turn on the windshield wipers in the next car I get into, or is the headlights on? Because every car maker puts those switches in a little bit of a different place. That's not necessarily a delightful experience, especially if you're jumping from vehicle to vehicle to vehicle. APIs should be the delightful experience. I want to have that consistency as I'm going from individual services so I can focus more on what the service is providing me and not the idiosyncrasies of, okay, what's the format of your request and response headers, or how do you build out your JWT claims? I want to have that as a consistent experience. And then from the enterprise standpoint, again, being able to have that investment of, I was able to invest once, I can have portability across any environment, public or private. I can move these APIs around. I'm not tied to, did I build this as an edge solution? Did I build this as a micro solution? Did I build this as an enterprise solution? They all deliver it through a consistent approach with the same runtime capabilities and experiences everywhere. From a multi-cloud observability, which was one of those issues I brought up earlier, all the different platforms, if we do it individually, have different ways of reporting analytics information. Having a unified gateway strategy allows me to take all that metadata that the gateway is being able to generate and provide them in a consistent format. So that way I can start doing deep analysis on who's using my APIs, how are they being used with consistency, so I can, again, spend more time in looking at the data and not trying to normalize the data into a single format to then process the information. So I can get better and faster insight into the different trends and opportunities. And lastly, again, providing that consistent security everywhere. Being able to deliver that model where the CISO team, the different architects can say, here's the security we want. We want TLS 1.3. We only want certain crypto profiles. We want to be easily able to add mutual TLS across all of our endpoints. We want to be able to do revocation lists. We want to be able to support OAuth and OpenID Connect, and do it the same way no matter what the API is behind the gateway in any cloud, in any on-prem environment. Again, being able to do that and then saying, all right, our security policies changed. I don't want to support that crypto cipher, this one specific cipher in the TLS 1.3 settings anymore. I want to disable that one and do it across all my gateways and all my environments. I can do that easily if I have a common approach. If I have to go into each and every vendor, some might say, oh, we don't support disabling it at that fine-grained levels. Others might say, oh, well, we don't even support 1.3 yet. Others might say, oh, we can disable that, but that's going to require additional customization and testing. So, and your operational teams and development teams, support teams have to figure out, how do I go about doing all those changes? So that ability to have consistency and flexibility is really that main goal. So, kind of in a wrap up, we can see that there's a massive number of benefits to this federated gateway approach. It's easy to build siloed gateways. It's easy to build siloed systems. It tends to be the path of least resistance. But is it the path that's the best in the long run? Once we start going beyond a single API or a small set of APIs, once we get into that, I need to start thinking about cross-line of business. I need to start thinking about multi-cloud. I need to start thinking about how am I going to manage security? How am I going to manage high availability, disaster recovery, all these other things we haven't even gotten into yet. If I do it on different platforms, I got to resolve the same problem over and over and over again, because each of those platforms are going to do it differently. Where if I choose a consistent multi-cloud federated approach, I gain that lever because that speed, because I'm doing it in a single unified fashion. So with that, I'd love if you're interested in more of what IBM has in this offering space. We have some links here from API management specific use case and industry examples, as well as our whole integration platform, which looks at pulling in the capabilities of API management, application integration, messaging, high-speed data transfer, event-driven architecture, all into a unified developer experience. And we have two different trial experiences you can do. We have a free trial of our API Connect multi-tenant SaaS offering, which is brand new as of last month. Over on AWS, you can try it for free, as well as we have, if you're more interested in the Cloud Pak for integration, which again brings all the different integration capabilities together, we also have a free trial for that as well, and encourage you to check out both. So with that, I can put that. I saw a few people trying to get photos of those links. With that, I can open it up for questions, or if people want to get an early move to lunch, we can end this up. Again, I thank you for your time.